Welcome to lesson 1.4 on the radical rules. Our goal today is that you are able to apply radical rules to questions to simplify expressions, and that you're able to convert between mixed radicals and entire radicals. I'm also going to teach you how to rationalize a denominator, and that'll be something that's important for those people who are going on in 4U math. First of all, we're going to cover some vocabulary. Now, this is going to seem, some of this vocabulary you don't necessarily need to know, but just in case you come across it at some point, it's good to know what we're talking about in terms of terminology. Okay, so I've tried to draw here the nth root of a. So last lesson we looked at rational exponents and we found like an exponent of 1/4 is really the fourth root. Okay, so the n would be like the 4, and then we've got the root sign, and then we've got the thing underneath the root sign, the radical symbol. So we're going to label these things. The n is what we call the order. So if the n isn't written, it's order 2 or square root. If it's any other order, you have to put that number there, so cube root or 3 root, the third root, the fourth root, the fifth root, and so on. So the n is the order. The thing under the radical symbol, the a, that's called the radicand. Again, that's not something you come across all that often, but I thought I better put that in case you see that at some point. And then this is called the radical symbol. So we've been calling that the square root in previous classes because that's really what we were using, but then we also had cube root, but we've now bumped that up to other orders. So this really is your radical symbol, radical symbol, and the whole thing is called a radical. Okay, so if you put it all together, it's a radical. Okay, so we are looking at rules for radicals. Now I'm going to focus on square roots because that's really what we're comfortable with, but any of these rules can be extended to any order of a radical, so as long as the orders are all the same. So if they're all fourth roots or all fifth roots, the rules will still apply. It's just the orders have to be the same for the rules to work. So keep that in mind when you're doing that, and you might want to make a little note somewhere about that at some point. Now, another thing I want to do in terms of vocabulary, I'm going to do another piece off to the side here. If you plug the square root of 72 into your calculator and get that answer, you will find that that answer is the same thing as 6 times the square root of 2. Okay, you can check that on your calculator. You can do 6 times the square root of 2, get that answer, get the square root of 72, and just make sure they are equal. I think I've done that correctly. But what I want to show you here, this part, the square root of 72, everything's entirely under the radical symbol. So we call that an entire radical. Okay, it's like when we were working with fractions and we made the whole thing into a fraction, even though the top might have been bigger than the bottom, we called that an improper fraction. This is kind of like that, except it's really not a fraction at all, so we can't use that term, but there's no whole parts to it. It's all under the square root sign is really what I'm trying to say there. Versus this one, which it has part of it under the radical symbol, but part of it's not under, and so we call that one a mixed radical. Okay, so part of our learning goals is to distinguish or be able to convert between mixed radicals and entire radicals, and we're going to learn how to do that right off the top. Because if we can do that, it'll help us apply the rules that we have to apply. All right, our example here is express each mixed radical in lowest terms. Now, to do this, it's really super helpful, like I can't stress that enough, to know what your perfect squares are. So, for example, 1 squared is 1, and then 2 squared is 4. So 4 is a perfect square. 1 is a perfect square, 4 is a perfect square. 3 squared is 9, 9 is a perfect square. 4 squared is 16. And, whoops, I got my numbers mixed up. I'm going to keep writing those down. I'm going to put the video on pause, though, and write those down. And you should put them somewhere where you can refer to them on a regular basis. I might hang a chart in the classroom if I can find a space to do that. Okay, I've just listed the first 10 perfect squares. If you can put those in your memory bank, it's really helpful. because we need those perfect square numbers to help us write things in their mixed form. So what we do for that, I have an entire radical of the square root of 50. I'm going to look at my list and I'm going to look for the biggest number that will divide into 50 that is a perfect square. So 49 is too small, that's not going to work. And 36 won't divide evenly, but 25 will. So I'm going to take 50 and express it as the product of 25 and another number. So 50, whoops, wrong tool. 50 really is the same thing as 25 times 2. So the goal is to write the number, the radicand, the number under the square root sign, as the product of a perfect square and another number. If I had a cube root instead, and I wanted to do it as a mixed radical, I'd be looking for a perfect cube that would divide the radicand. And if it was a fourth root, I'd be looking for, well, you get the idea, I hope. You would be looking for one of the numbers that to the exponent of 4 ends up being in our list. All right, now the reason I do this is because the square root of 25 times 2 will be equivalent to the square root of 25 times the square root of 2. And you can check that on your calculator. You can check this line, put that the square root of 50, make sure that you get that answer, and then you can check this line, do the square root of 25 times the square root of 2. Those should give you the same answer. Now the reason I did the breakup here is because I can actually take that square root of 25 and I get 5, and that's going to multiply the square root of 2. So that's a big 5. It's not like the fifth root of 2. That says 5 times the square root of 2. Okay, try B. See if you can find a number in our list over here. Okay, this list over here, that will divide 48, write it as the product of that number and another, and then write it as a mixed. Same with C. Try that. See what you can do. Put the video on pause. Give it a try, whatever. Okay, hopefully you've had a chance to try that. I found that 48 is the same as the product of 16 times 3, and so 16 was one of my numbers on that list that we had. That means I could write that as the square root of 16 times the square root of 3, which is equal to 4 root 3. 4 times the square root of 3. The next one, this 5 is just going to stay out constant. So I'll have 5 times, and then we've got the square root of 27, which I could write as 9 times 3. And I picked 9 because 9 is a perfect square. It's the biggest perfect square that divides 27. I'm going to have 5 times the square root of 9 times the square root of 3. And I don't have to put a times sign in there. You can if you want. Then we have 5 times the square root of 9 is 3, and then times the square root of 3. And 5 times 3 now, I can simplify these two to get 15 times the square root of 3. All right, to go from mixed, express each as a mixed radical in lowest terms. I think I made a mistake when I typed this up. That was supposed to say entire. Oops. Okay, first time through, I'm going to have mistakes as we go along. I'll try and fix them. All right, so what we do is the process backwards. I'm going to start with 4. I look on my list over on the side here, and I have, whoops, just changing colors, 4 to the exponent of 2 is 16. So I'm going to rewrite that 4 as the square root of 16. Square root of 16 is 4. I'm just working backwards. That's going to times the square root of 5. Things that are under the square root sign can just get multiplied together. As you get going, you will start to leave out some of these steps probably. If you can't, that's quite okay. I'm perfectly fine with that. But if you start to leave out steps, it's okay. Just don't leave out too many and then make mistakes. So there we are. 4 times the square root of 5 is equivalent to the square root of 80. The next one, the negative sign just it has to stay out. My final answer has to be a negative. If I were to make that a square root of negative 36, that actually, you can't square root a negative number in the real number system. So the negative has to stay on the outside. 36 times 3 is what we're going to get there. And again, you might just jump this step, jump one of these steps. 36 times 3, that gives us 108. So that'll be negative the square root of 108. All right, and the last one, 8 squared is 64, so we'll have square root of 64 times the square root of 2. As I said, you might want to jump a step. You could go to that. That'll be the square root of 128. All right, hopefully that makes sense. I'm going to stop this video and then we'll go on to the next video with multiplying radicals.